Hot air balloons. They grace our skies with vibrant colors and a sense of wonder. But have you ever stopped to think about the science behind their flight? It's all about physics, specifically the principles of buoyancy, temperature, and forces. In this exploration, we will unravel the mysteries of hot air balloon flight, delving into the fascinating interplay of heat, air density, and the forces that allow these gentle giants to soar. Get ready for a journey into the captivating world of hot air balloon physics. The story of hot air balloons begins in the 18th century with two French brothers, Joseph and Étienne Montgolfier. These brothers were not just ordinary men, they were visionaries who dared to dream of conquering the skies. Born into a family of paper manufacturers, they had access to materials and resources that would later prove crucial in their experiments. As owners of a paper mill, Joseph and Étienne were deeply involved in the industrial processes of their time. They were constantly surrounded by the hustle and bustle of paper production, which sparked their curiosity about the natural world. The idea of flight was not just a passing fancy for them. It was an obsession that consumed their thoughts and conversations. One day, while observing the smoke rising from a fire, they noticed that it carried small particles of paper upwards. This simple yet profound observation led them to wonder about the properties of hot air. Could it be that the heat from the fire was causing the air to rise? And if so, could this rising air be harnessed to lift objects? The brothers began to brainstorm and conduct experiments. They tested various materials and designs, meticulously documenting their findings. Their scientific curiosity and relentless pursuit of knowledge drove them to explore the potential of hot air as a lifting force. They experimented with different shapes and sizes of balloons, trying to find the perfect combination that would allow them to achieve flight. In 1783, after countless trials and errors, the Montgolfier brothers made history by launching the first unmanned hot air balloon. This was no small feat. It was the culmination of years of hard work, dedication, and innovative thinking. The balloon, made of linen and paper, was filled with hot air generated by a fire, and it soared into the sky, defying gravity and capturing the imagination of all who witnessed it. The sight of the balloon ascending into the heavens was nothing short of magical. Onlookers were captivated by the spectacle, their eyes wide with wonder and amazement. The Montgolfier brothers had not only achieved flight, but had also ignited a sense of possibility and adventure in the hearts of people. Their creation, though simple in design, represented a monumental leap forward in human ingenuity. This groundbreaking achievement marked the birth of hot air ballooning and opened up new frontiers in aviation. The Montgolfier brothers' dream had become a reality, and their pioneering work laid the foundation for future advancements in flight. Their story is a testament to the power of curiosity, innovation, and the relentless pursuit of dreams. It reminds us that with determination and creativity, even the sky is not the limit. To understand how hot air balloons work, we need to delve into the fascinating concept of buoyancy. This principle is not only crucial for hot air balloons, but also for many other objects that float or rise in fluids. Buoyancy is the upward force that a fluid, like air or water, exerts on an object submerged or immersed in it. This force is what allows objects to float or rise, counteracting the force of gravity. Imagine an object submerged in water. The fluid exerts pressure on all sides of the object, but the pressure at the bottom is greater than the pressure at the top. This difference in pressure creates an upward force known as the buoyant force. Think of a boat floating on water. The boat displaces an amount of water equal to its weight. This displacement is key to understanding buoyancy. As the boat displaces water, it creates an upward force that counteracts its weight. This force is the buoyant force, which keeps the boat afloat. Without this force, the boat would sink. The buoyant force is directly related to the amount of fluid displaced by the object. In the case of the boat, the water displaced is equal to the weight of the boat, allowing it to float effortlessly. The same principle applies to hot air balloons. However, instead of displacing water, hot air balloons displace air. The key to their operation lies in the difference in density between hot air and cold air. The balloon's envelope, when filled with hot air, becomes lighter than the surrounding colder air. This is because hot air is less dense than cold air. As the air inside the balloon heats up, it expands and becomes less dense, causing the balloon to rise. This difference in density creates an upward buoyant force that lifts the balloon. The greater the temperature difference between the hot air inside the balloon and the cold air outside, the stronger the buoyant force, and the higher the balloon can rise. This is why hot air balloons are often seen soaring high in the sky, providing breathtaking views of the landscape below. Pilots can control the altitude of the balloon by adjusting the temperature of the air inside the envelope. By heating the air, they can make the balloon rise, and by allowing the air to cool, they can make it descend. This delicate balance of temperature and buoyancy allows for a smooth and controlled flight. Understanding buoyancy not only helps us appreciate the science behind hot air balloons, but also gives us insight into the principles that govern the behavior of objects and fluids. Whether it's a boat on water or a balloon in the sky, buoyancy is a fundamental force that makes these incredible feats possible. So next time you see a hot air balloon gracefully floating above, remember the fascinating science of buoyancy that makes it all possible. It's a beautiful blend of physics and adventure, lifting our spirits as high as the balloons themselves. Molecular dance. How heat changes air density. But why is hot air less dense than cold air? The answer lies in the behavior of air molecules. When you heat air, its molecules absorb energy and start moving faster. This increased motion causes the molecules to spread further apart, making the air less dense. Imagine a room full of people dancing calmly. Now crank up the music and watch as their movements become more energetic, causing them to spread out to accommodate their increased motion. Similarly, heated air molecules energized by heat require more space, leading to a decrease in air density. The forces at play: gravity versus buoyancy. Two main forces are at play when a hot air balloon takes flight: gravity and buoyancy. Gravity, the force that pulls everything towards the center of the Earth, acts on the balloon and its basket, trying to pull them down. On the other hand, buoyancy, the upward force exerted by the surrounding air, pushes the balloon upwards. When the buoyant force is greater than the force of gravity, the balloon rises. When the forces are balanced, the balloon hovers at a constant altitude. Steering the skies. How pilots control altitude. Pilots of hot air balloons have a unique and fascinating job. Unlike airplanes or helicopters, hot air balloons don't have engines or wings to help them navigate. Instead, they rely on the principles of buoyancy and temperature control to move up and down in the sky. If hot air balloons simply floated upwards, they wouldn't be very practical for travel. Imagine trying to reach a specific destination without the ability to control your altitude. It would be like trying to drive a car that only goes straight, without the ability to turn or stop. So, how do pilots manage to control their altitude and navigate the skies effectively? So how do pilots control their altitude? The answer lies in the careful manipulation of the air temperature inside the balloon's envelope. This process is both an art and a science, requiring skill and precision. The key lies in adjusting the temperature of the air inside the balloon's envelope. The envelope is the large, colorful fabric part of the balloon that holds the heated air. By controlling the temperature, pilots can make the balloon rise or fall as needed. To ascend, the pilot heats the air inside the balloon using a burner located beneath the envelope's opening. This burner produces a flame that heats the air, causing it to expand and become less dense. As the air inside the envelope becomes warmer and less dense than the cooler air outside, the balloon begins to rise. This heating further decreases the air density inside the balloon, increasing the buoyant force and causing the balloon to rise. The principle at work here is similar to how a hot air balloon floats in water. Just as a boat floats because it is less dense than the water it displaces, a hot air balloon rises because the heated air inside is less dense than the cooler air outside. To descend, the pilot allows the air inside the balloon to cool naturally. This can be done by simply turning off the burner and letting the air inside the envelope lose heat over time. As the air cools, it contracts and becomes denser, which reduces the buoyant force and causes the balloon to descend. As the air cools, its density increases, reducing the buoyant force and causing the balloon to descend. Pilots can also release some of the hot air from the envelope through a vent at the top of the balloon. This allows cooler air to enter, speeding up the descent process. By mastering these techniques, hot air balloon pilots can skillfully navigate the skies, providing a safe and enjoyable experience for their passengers. Beyond hot air balloons. Exploring other physics phenomena. The principles of buoyancy and density that govern hot air balloon flight are fundamental to understanding a wide range of natural phenomena. From the flotation of ships to the formation of clouds, physics plays a crucial role in shaping our world. So the next time you see a hot air balloon gracefully drifting across the sky, take a moment to appreciate the elegant interplay of physics at work. And as you marvel at this feat of engineering, consider this. What other everyday wonders can be explained by the laws of physics? The possibilities for exploration are endless.